So in this video, we are going to look at task 8, the first 3 questions where it says properties of triangles, and we're going to study this diagram and look at different angle relationships in triangles. So it says triangles are very important tools in building because of the rigidity that they provide. Triangles disperse the mass that they are supporting better than any other structure. Consider the following triangle. Around each vertex, there are 4 angles which all have been approximately measured. Okay, so question 1 says, around each of the vertices, you should have noticed a pattern in the angle measures. The type of angle with this pattern was already mentioned in a previous task, vertical angles. Can you make a statement about pairs of vertical angles? So if we look, these 2 angles are across from each other. They're formed by intersecting lines and are vertical. These 2 are vertical. These 2, this 37.39 and this 37.39 are vertical. This angle A and this part of angle A are also vertical, and notice they're the same measure. And then on B, this part of B and this part of B are vertical and the same measure. And this part of B and this part of B are vertical and the same measure. So you should see a pattern that all of the vertical angles have the same measure. So what we can always say about vertical angles is that they are congruent, right, which again means they have an equal measure. Okay, and that's a very important property in geometry that we use a lot. So it's very important that you remember that property. Okay, so the next question says, is there a relationship between BCA? So let's trace this. Okay, so B to C to A is this angle here. CAB, okay, so if we start at C and trace it to A to B, that's this angle. And then ABC, if we start at A to B to C, that's this angle. Okay, so if we take those 3 angles, we know they're in a triangle, and you may know this property because it is pretty well known about triangles. But if we take those 3 angles and we add them together, they will add up to 180 degrees. And for any triangle, that is always true. I think these add up just because their approximate measures slightly off, but they should all be 180 degrees when you add up the 3 angles in a triangle. So like I said, these add up to 180.01. So it's slightly off, but all the and it's just because they're approximate measures, but triangles, the 3 angles of a triangle should always add up to 180 degrees. And then the next question is the relationship between BCA. Okay, so BCA is this angle again. CAB, so CAB is this angle. And the supplement to ABC. So ABC is this angle here, this 57.89, and the supplement is this angle here. Okay, or you could say this other 122.11, it doesn't matter, they're equal. This angle here is the supplement, and remember, supplement means that they share a side and a vertex and they add up to 180. So you could pause and try to figure out and think about, okay, how does this angle relate to these 2? And what you should find is that if you add 37.39 and 84.73, you should get, if you add those up, you should get 122. Now, these are approximations, so it's a little bit different, slightly different by a 100th of a degree. You get 122.12. And if you look, this is 122.11, so they're almost equal, and they should be equal. It's just, again, a slight measurement off due to like approximate measures. So what we find is that in this case, angle BCA plus angle CAB is equal to the supplement of angle ABC. And this is a big theorem in geometry that we will define and talk about on the next few slides. Okay, so what we found, and you could go to this GeoGebra to help you see this as well. I have it open. So this is just to kind of help you see that if you have three angles in a triangle, no, this is for the exterior angle. Come back to that. Okay. You should find that three angles in a triangle always sum to 180 degrees. Again, this is a very important property that you need to make sure you know. So the interior angles are the three angles inside the triangle. They should always add up to 180. Okay, the exterior angle theorem is this applet that I wanted to show you. And so what we saw was like the supplement of that one angle and these two angles, they were equal. And so if you look at this applet, if you take those two angle measures and kind of rotate them and slide them in, you can see that those two together give you this exterior angle. And that is called the exterior angle theorem, and it works for any triangle. So what the exterior angle theorem says, I'm going to draw a picture. So this is the exterior angle. And I'm going to call it angle 3. And I'm going to put 1 and 2 here. And 4 here. These two angles that are inside are called interior. And the two angles that are inside that don't touch this exterior angle are called the remote interior angle. Okay, and no, I can draw this a lot of different ways. I could draw my triangle like this again, and then I could extend this side and put an angle here. And then this is the exterior angle. And now these two are the two remote interior. So it depends on what exterior angle you're looking at. So whatever exterior angle you're looking at, the two interior angles that are not touching that exterior angle or that are not supplementary to that exterior angle are called the remote interior. And what the exterior angle theorem says is that the exterior angle is equal to the sum of the two remote interior angles. And if I'm going to write this kind of in like with symbols with my diagram, if I'm referring to my first diagram, I'm going to say the measure of angle 3 is equal to the measure of angle 1 plus the measure of angle 2. Okay, this exterior angle is equal to that. So we don't get confused. Let me just change the angle numbers in this diagram to be like 6, 7, 8. And so in this one, how it would be is that the measure of angle 5, that exterior angle is equal to the measure of angle 8 plus the measure of angle 6. Okay, so this exterior angle is equal to the two remote interior angles, and the two remote interior angles are the two interior angles that are not supplementary to that angle. And the question is why? Like, why does that work? Well, if we show it kind of with algebra, what we know just from angles and triangles, we know that if I use this first diagram, that angle 3 and angle 4 have to add up to 180 because they're supplementary angles. They form that straight angle. And we know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 4 equals 180 because those three angles are the interior angles of a triangle, which always add up to 180. And then when I have two things equal to the same thing, what I can do is I can set those two expressions equal to each other. It's called the transitive property or substitution if you learn from algebra. But because this expression equals 180 and this expression equals 180, these two expressions have to be equal. And then if I do a little bit of algebra, I see that I have an angle 4 on both sides. And so I could subtract the measure of angle 4 from both sides and they would cancel out on both sides. And so I find that I can see that the measure of angle 3 is equal to the measure of angle 1 plus the measure of angle 2. Okay, so that's like the algebra proof of why that is true. And if you want to say it in words, you can say that the exterior angle is supplementary to the adjacent interior angle. Okay, and remember adjacent means that it's right next to each other. It shares a side and a vertex. So in our first diagram, angle 3 and 4 are the adjacent angles, and angle 4 is the adjacent interior angle. So the exterior angle is supplementary to the adjacent interior angle. That interior angle is also supplementary to the sum of the remote interior angles. And then two angles that are supplementary to the same angle are always equal. So if you have two angles, again, we kind of showed it here. Like these two angles add up to 180, these three angles add up to 180. I can take angle 4 from both of them, which are the supplements, and therefore these two angles together add up to angle 3. And that's the exterior angle theorem. And the other thing that Atlas shows is what I could do is if I cut out angle 1 and 2, I could put them together to get angle 3. And that's another way to show the exterior angle theorem. Okay, so that's what I'm going to do in this video, and then I'll talk about the rest of it next video.